All right, we're going to go ahead here and we're going to run a couple t-tests. In this video, I'm going to do a dependent samples t-test, a paired samples t-test, as well as an independent samples t-test. I think I just said that wrong. I'm going to start with the one sample t-test, and then I'm going to go on and do the paired sample t-test, also known as the dependent samples t-test, and then finally the independent. So one sample, paired dependent, which is the same thing, and then independent. There we go. I've got my head on straight. Okay, so this data here, again, from our 8th grade students, all hypothetical, stacked this data, so it'll give us pretty examples. Some of the things that we have in here are, for example, their Pennsylvania Standardized Math Assessment test. The other things we have in here are these behavioral outcomes. So this is a data set with students from 2 different school districts. Some of the students are having this PBIS intervention programming in their school, which is a behavioral program that helps students build positive behaviors. Some students are getting that, some students aren't getting that. We've got students in 2 different districts, students categorized by different ethnicities, and then we have these behavioral scores, right? So what's happening for these kiddos the beginning of the year, and for some of them, we also have that data at the end of the year. The behavioral scores tend to range from 0 to 2 in this data set, and higher scores are better than lower scores. Great. So let's look at some t-tests. The first thing I'm going to do is go to the one sample t-test. So the one sample t-test is a cool little test that you can use when you've got one set of information, like one variable, so to speak, and you want to know, okay, this is the average score that my people have on this. How normal is that? So you're not comparing 2 groups. You've got one group of people, they've got an average score on something, and you just want to know how normal their average score is. So for example, in this group, they've all taken this standardized math test. What if we wanted to look and to see whether their average score on that math test is like normal? Is it like way above average, below average? Like, where are these kiddos? We would use a one sample t-test for that. So we pop it over into the box here, and it gives us some very basic output here. It gives us the t-value, degrees of freedom, and a p-value. And what it says down here is that it's looking to see if the mean is different from 0, right? Well, I don't know that we want to test it against a 0, right? Typically, students aren't getting a score of 0. But what we could do is go in here and change the test value to what is like a general normal kind of score. So for example, happen to know that 1000 is a cutoff score for this math test that cuts you off at proficient. So 1000 is where the cutoff starts for a proficient score. So what if we said, how did these kiddos do compared to a score of 1000, which is the proficiency score? Let's click on a couple other boxes quickly. Let's get the effect size and the descriptives. It'll help us interpret this more. So now we know we've got 500 kiddos. They have an average score of 1,112.01. Okay, we've got a standard deviation around that. We've got a standard error around that. Beautiful. So they're scoring a little bit above 1,000. We know that 1,000 is the cutoff for proficiency, and we test here to see if the mean, this number here, is different from 1,000. We get a t-statistic of 16.45, p-value that's very tiny, and a Cohen's d that, quite frankly, is very large. What this is telling us is, yes, this is significant. So what might that look like if we wrote it up? I'm going to be very brief here. Always consult with the person in charge about how they would like to have things written up. But I'll say a one sample t-test was conducted. Why? To compare the average PSSA score for the 500 8th graders to the cutoff for proficiency of 1,000. I apologize if there's typos in here. The t-test, that one I caught, was significant. I'm going to go over this in just a second. Don't panic about where these numbers are coming from. With a large effect size. 7.30. Okay. The average of 1112.01, standard deviation 15224 was significantly higher than a cutoff of 1,000. All right, so first of all, we tell people what we did. We ran a t-test, a one sample t-test. Why? Because we wanted to compare the average PSSA score for our 8th graders to the cutoff proficiency score of 1,000, and then we tell them what we found. First of all, the googly glop, right? What is this stuff here? Well, that comes from our t-test table, right? We're going to tell them that the t-value we got was equal to 16.45, right? See that right here? The t-value is 16.45. APA tells us we have to add this little detail in there. So right next to the t, in parentheses, we report out the degrees of freedom, which is right next to it here. And then we give them the p-value, which is listed right here. Okay, because the p-value is very small, it is significant. P-values less than 0.05 are considered statistically significant. We also got Cohen's d, which is the effect size. When we click this button here, I'm going to uncheck it. Watch what happens. Cohen's d goes away. When I say, please give me the effect size, Cohen's d comes back. That is the measurement of the effect. It is 7.30, and that is a large effect size. So we can conclude then that the average score, I reported it here, which is down here in this table, is significantly higher than the cutoff of 1,000. Yes, it's significant because our p-value is very small, right? I've listed this out in a very particular format for APA purposes, that m equals this, and right next to it in parentheses, I've put the standard deviation. So this is a quick and easy test to show us that the average PSSA score, this one score for this one sample, is different than this cutoff score. And we put the cutoff score over here. They call it the test value to give us that comparison. Easy peasy. Let's take a look at the next t-test. So the paired samples t-test, some people will also call this the dependent samples t-test. This is where we're pairing up two things to see how they compare to each other. Not groups, but actual scores, right? We're going to have two averages for kind of the same thing that's been repeated perhaps, or two things that are supposed to be very similar. An example of that would be the behavioral scores that we have here, right? They pair with each other because they're the same thing. We just recorded them at two different points in time. Again, I'm going to ask for effect size and descriptives on this. And the output, let me scroll this a little differently for us. The output here looks similar to the output that we saw for our other t-test, but it's slightly different. In here, we have it showing us specifically that we're comparing the year start behavior score to the year end, but then it gives us a degrees of freedom, a p-value, and an effect size. And down here, instead of one average score, we have two. We have the average score at the beginning of the year and the average score at the end of the year. And as you can see, those average scores, it is higher at the end of the year than it was at the beginning of the year. Is it significantly higher? Let's take a look at our p-value. Yes, we have a tiny p-value of 0.001, which is less than our 0.05. So that is, in fact, telling us that it's significant. I'll also argue that this is a large effect size. So we would write things up very similar to how we did before. A couple slight changes. We did a different test, right? So we have to say that a paired samples t-test was conducted to compare the what? The year start and year end behavioral scores. The t-test, what was the results? Those was significant. We put that googly glop in here. We are going to tell them what the t-value equals, which is right here. Where'd my mouse go? Which is right here. But first, we've got to report the little degrees of freedom in there. Okay. Don't worry about whether your t-test is positive or negative. All that is dependent on is which one of these numbers was bigger, right? Because it's subtracting. So if it subtracts the bigger number, then the smaller number from the bigger number will be positive, vice versa, it'll be negative, but that's not, it's not impacting the results of your study. Put our p-value in with a large effect size. The Cohen's d, negative 1.78. Same thing with Cohen's d. It's the absolute value that's important here for the magnitude, not necessarily the direction. The direction just depends on whether you subtracted the little number from the big number or the big number from the little number, but it's the same magnitude. Okay, so the start year average of scroll down a little so we can see that. I'm going to get these numbers from down here of 0.90 with a standard deviation of 0.50 was significantly lower than the average at the end of the year, with a mean of 1.18 and a standard deviation of 47. I see a little typo in here. It's one that I'm going to catch. All right. So repetitive. What kind of test did I run? What was I looking for? Paired sample, looking at the start year to the end year. Was it significant or not? Give me the actual statistics out of this top table, and then tell me a little bit about the average scores and what they looked like and what the interpretation is. All right. So those are our first two t-tests. And then we are going to do the independent samples t-test, the one that we use all of the time. The independent samples t-test is where we take something, some kind of score, and we get the average for this group and the average for that group, and we look to see if those two groups are similar or different. It only works for two groups, and it is a very popular and easy test to do. So for example, what if we decided to look at that behavioral score at the end of the year? We pop that in the box, and we look to see if it's different between the two districts. Simple question. Students behaving the same way in the two different districts. We can get our effect size, we can get our descriptive statistics. Shrink this up a little bit so we can see it a little better. And very repetitive. You're starting to see this, right? You get the t-test table, and then you get your descriptive scores. In the t-test, we've got our t, we've got our degrees of freedom, and we've got our p-value, which is very, very tiny. What does that mean? We have a significant finding here. We still have a relatively large Cohen's d value, so the effect size is still large. And if we go down here to look, here's District A, here's District B. District A has a score that is significantly higher than District B. Great. Let's see what that looks like when we write it up. All right, first things first, what did we do and why did we do it? An independent samples t-test was run. That's what we did. Why did we do it? To see if the end of year behavioral score was the same or different between District A and District B. What did we find? The t-test was significant. Significant. We put our special little numbers in here. Remember, we just put that degrees of freedom in there with the parentheses before putting out the actual t statistic. Then our p-value with a large effect size. And here comes our Cohen's d. The average for District A was higher. M equals 1.29. Our standard deviation right next to it in parentheses compared to District B. And District B had 0.94 and the standard deviation was 2.1. All right. I want to separate this by commas because I'm going to be a little picky here for a second, and same thing there. Feeling repetitive, I hope. This is going to be consistent throughout all of the tests that you do, right? What did you do? Why did you do it? What did you find in terms of the Googly Glop? And then what does that mean when we talk about average scores or percentages in groups or whatever it is that the context is you're looking at? All right, so there we have it. 3 quick t-tests for you to see. Please be careful thinking about which one you're supposed to be doing. Do you have one number that you're comparing to some kind of standard? Do you have 2 things that should be paired to each other because it's the same people that took this, the start year, end year, the pre, the post? Or do you have 2 distinct groups and you're comparing the averages between those groups? That will help you decipher which test you should do. The buttons are easy to click. The output is very repetitive in terms of how you write it up. So have fun with your t-tests.